In this video, I'm going to explain the operation of the transistor as a digital switch. The transistor can operate in three different regions: the cutoff region, the active region, and the saturation region. We're going to focus mainly on the cutoff region and the saturation region. In the cutoff region, what happens is that the current into the base of the transistor is very, very low. When the current into the transistor is very, very low, the internal resistance of the transistor is extremely high, which means very little current will be able to flow into the collector. We're talking on the order of gigaohms or megaohms. Because the current into the collector is very, very low, that means very little current will be able to flow through the lamp into the transistor. So for all practical purposes, we say the transistor is acting like an open circuit. For all practical purposes, the transistor is acting like an open circuit. So if very little current is flowing into the base, then the transistor will act like a large resistor, and because of that, very little current will flow into the transistor. So actually, the transistor is blocking the current from coming from the power supply of 12 volts. So if the current is very small, the lamp will be off in this position. Now, if I close the switch, then what I have done is I have connected the 5 volts through the resistor into the base. And now I have current flowing into the base. And I've calculated the right resistor such that enough current will flow into the base to move the transistor from the cutoff into the saturation region. If you study the data sheet, you will learn that once the transistor is into the saturation region, the resistance of the transistor from the collector to the emitter becomes very, very small. And the data sheet tells us that the voltage drop between the collector and the emitter can be as low as 0.2 volts in this region. And that is because now you have saturated the transistor. If you look up the word saturation, it basically means it cannot hold enough. There's too much. So it has saturated. It cannot hold any more. So it is at its limit. However, the transistor is still good. It's just not acting in the normal capacity of a current gain device. So we can use this to act as a closed switch. So now the current can freely flow out of the battery of the 12 volts into the transistor. Of course, in the emitter, the current from the collector and the current from the base will add up. But typically, the current from the collector would be much, much larger than the current in the base, sometimes on the order of 10 to 100 to even 1,000. What that means, if you do your math, it basically means that if you have 5 milliamps of current over here, then that can translate into 500 milliamps of current over here based on the specifications of the transistor, or even higher. Looking at this, we can conclude that a low current is able to control a high current. So you can think of this as circuit number 1. And you can think of this as circuit number 2. And we've studied series circuits before. So you can think of this as a series network flowing from the 5 volts through the switch, through the resistor, from the base to the emitter to ground. That will be your first circuit. And your second circuit would be over here, where it starts off with 12 volts, goes through the lamp and the resistor, from the collector to the emitter to ground. That will be your